Okay, so this is the test review for the parent functions and transformations. So problem number 1 was y equals x plus 2 squared minus 4. For part A, you had to state the parent function. The parent function for y equals x plus 2 squared minus 4 is quadratic, and the quadratic parent function is y equals x squared. Part B, you had to list the transformations. So for the transformations, this plus 2 in parentheses, remember when it's in parentheses, that means it's a left or right movement, and in this case, plus 2 would be moving it to the left. This minus 4 that's out here on the outside, when it's on the outside like that, it moves it up or down, and a minus 4 in this case moves the graph down 4. Part C, we need to sketch a graph. So what I'm going to start with my red pen is I'm going to draw in the quadratic parent function. So that's the quadratic parent function. And I'm going to take that quadratic parent function and I'm going to shift it left 2 and down 4. So I'm going to take this point, this vertex point, I'm going to go to the left 2, 1, 2, and I'm going to go down 4, 1, 2, 3, 4. That's going to be my new vertex. Then I take the next point and I do the same thing, left 2, 1, 2, 1, 2, 3, 4. Then I'm going to take a point on the other side of the parabola and do the same thing, 1, 2, 1, 2, 3, 4. And there's my new parabola in black. So the red one was the parent function. This one in the black pen is my transformed parabola. So this is the one that's for the answer. Now, if you don't need to draw the parent function on your graph and then do the movement, then that's fine. I drew it there just so that we could see which one we were talking about. Okay? And I'm going to do that for every problem. I'm going to draw the parent function for you and then do the movement. But again, when you're doing your test or your review, if you don't need to do that, then that's fine. That's great. Part D, we had to list, or we had to state the domain and range of our transformed graph. So for domain is our x values. So our parabola is going on and on to the right and on to the left, so that means our domain is all real numbers. Remember, that's our symbol for all real numbers. Our range, though, is our y values. If I look at my parabola, my range goes from this point down here and up. So that point down there is -4. All of these y values on this parabola are greater than or equal to that. So our range is y is greater than or equal to -4. Number 2. Our problem is y equals log of x minus 1 plus 3. So log of x minus 1 plus 3. Part A, we have to say the parent function, and the parent function in this case is logarithmic, or y equals log x. Part B is the transformations. So the transformation here, this minus 1 in parentheses, remember when it's inside parentheses, that's a left or right movement, and the minus 1 is a right. So it's right 1. The plus 3 on the outside is an up or down movement. In this case, it's plus, so it's up 3. Part C is our graph. So again, I'm going to draw my parent function in here. For the logarithmic, we have an asymptote at x equals 0. We have the point 1, 0, and we have the point 10, 1. And we have the point over here, so it gets close to there and goes down. So it's something like that. It's not a very good drawing, but you get the idea for the parent function. And now I'm going to use my black pen and I'm going to do these movements. I'm going to move to the right 1 and up 3. If I move to the right, so does my asymptote. So my new asymptote moves to the right and ends up right there. So then I take this point, move to the right 1, and I move up 3. This point needs to go right 1 and up 3. And then I'm going to sketch in my graph. Remember, the red one is the parent function, the black one is the new transformed one. Remember, if you transform something with an asymptote, the asymptote is going to move also. So this asymptote moved to the right. So part D, domain and range. Domain is our x's. Our x's for this new function have to be greater than 1. So our domain for this y equals log x minus 1 plus 3 is x is greater than 1. So all the x is greater than 1. The range is all real numbers, because it goes on and on. Number 3. Y equals 2 to the x plus 3 plus 2. So part A, our parent function is exponential, which is y equals 2 to the x. Remember, we talked about it being y equals a to the x, but we use 2 to the x as our specific function. B is our transformations. This plus 3 that's in the exponent moves it left 3. And then this plus 2 out here moves it up 2. So our graph, I'm going to graph the parent function. And the exponential has a parent function, or has an asymptote of y equals 0. Okay, so remember, the red one is the parent function. Now I'm going to do the transformation. I'm going to move it left 3, so I'm going to pick a point to start with. I'm going to take this one. I'm going to move left 3, 1, 2, 3, and I'm going to move up 2. I'm going to move left 3, up 2. Left 3, up 2. Left 3, up 2. And sketch it in. Now, if we move our graph up, our asymptote has to move up also. So that asymptote that was y equals 0 now gets moved up to be at y equals 2. And those asymptotes are important for when you draw the graph. On the test, when you're asked to graph one of these and it has an asymptote, you actually have to show that on there. Okay, so for part D, for our domain and range, our domain is the x's. The domain is the x's. Is there any restriction on our x's here? No, so it's all real numbers. Our range, if we look at our range, as we move to the left, our line gets closer and closer and closer to that 2, but it never touches it. In the other way, it's getting bigger and bigger and bigger. So that means our range is y is greater than 2. Problem number 4 is y equals negative then x minus 1 cubed. So our parent function, because it's x minus 1 cubed, is cubic, which is the y equals x cubed. Part B, for the transformations, the first thing we have is a negative out front. A negative out in the very front means reflect over x. The minus 1 that's inside the parentheses means to move to the right 1. So those are our two transformations. We're going to reflect it over the x-axis, and we're going to go to the right 1. So again, I'm going to sketch in my parent function. Okay, and now I'm going to take that and do these transformations. I'm going to reflect it over the x-axis and go to the right 1. This point at 0, 0, it doesn't reflect over the x-axis because it's on the x-axis. So I just take it and I move to the right 1. The point 1, 1, when it reflects over the x-axis, it comes down here, and then I move to the right 1. This point up here at 2, 8 reflects over the x-axis. and then goes to the right 1. This point on the left that's underneath the x-axis, it flips to the top, flips above the x-axis, and then goes to the right 1. The point at -2, -8 flips up, and then goes to the right 1. And then I just sketch in my graph. So my cubic parent function was reflected over the x-axis and then shifted to the right 1. Number 5, y equals log x plus 3. Parent function is logarithmic, or y equals log x. For the transformations, we only have one thing that's different, and that's this plus 3. This plus 3 is outside. It's not in any parentheses. It's out by itself. So that means we take the logarithmic parent function and we shift it up 3. So for the logarithmic parent function, we have the point 1, 0 and 10, 1. And we have an asymptote of x equals 0. And now our transformation is to shift it up 3. If I shift this up 3, does our asymptote move? No, because if you shift a vertical line up, it just stays that vertical line. So I take these points and move them up 3. And then I'm going to sketch in my new graph. Okay, and domain and range. Domain is x's, and in this case, the domain has to be x's greater than 0. It can't be equal to 0 because we have an asymptote at that point. Our range is all real numbers, because the y can be anything. We're going to jump back to number 4 for a second, because I forgot to do domain and range. So if we go back to domain and range, domain for that function is all real numbers, because x can be anything. Same thing for range. Range can be anything, so it's all real numbers. Okay, so number 6. Y equals square root of x minus 4. So the parent function is square root, which is y equals square root of x. For our transformation, we have one thing there, and that's that minus 4. That minus 4 is underneath the radical sign, so that means it's a left and right movement. And in this case, minus 4 means going to the right. So we're going to take the square root parent function and shift it to the right 4. I'm going to sketch in our square root parent function. 0, 0, 1, 1, 4, 2, and 9, 3, and then make our line. Okay. Now I take that and I shift it to the right. That means every point goes to the right 4. So my starting point at 0, 0 shifts to the right 4. 1, 2, 3, 4. This point at 1, 1 shifts to the right 4. 1, 2, 3, 4. 1, 2, 3, 4. And that one I don't have enough room to shift it, so it's going to draw in my new graph. When I do domain and range, the domain, the x values start at 4. And then all of those x's are what compared to 4? They're all greater than or equal to 4. And it's equal because we have a point at exactly 4. Remember back on number 5, we didn't have a point at exactly 0, so we didn't put the equal sign. So make sure you know the difference between those two things. The range is very similar to that. The range starts at 0 and goes up, so that means our range is y is greater than or equal to 0. Because all of those y values are greater than 0, and we have a point at 0, so it's an or equal to. Okay, so number 7. Y equals the square root of negative x plus 4. So parent function is square root, which is y equals square root of x. For our transformations, we have two things. We have a negative underneath the square root sign, and we have a plus sign out and a plus 4 outside. That negative that's underneath the radical sign means that it's a reflection. But what kind of a reflection is it? Is it over x or is it over y? Since it's underneath the radical sign, it's over the y-axis. This plus 4 that's out here hanging out, that means it's an up 4. Remember, when it's not in parentheses, not under the radical sign, not in the absolute value, when it's outside like that, then it's an up or down. So part C. I'm going to draw my parent function. Okay. And now I'm going to do what we said for the transformation. I'm going to reflect it over the y-axis. So this point at 0, 0, it doesn't move. The point at 0, 0 doesn't move. And I just copied the problem wrong off the paper. Sorry guys, this plus 4 should have been a minus 4, which means it moves down 4. So our parent function is still square root y equals square root of x, and it's still a reflection over the y-axis. It just should have been down instead of up. I copied the problem wrong off the paper. So I did my parent function. Now I'm going to do this movement. I'm going to reflect it over the y-axis. 0, 0 doesn't move because it's on the y-axis. And then I'm going to move down 4. 1, 2, 3, 4. The point at 1, 1, I reflect it over the y-axis, and then I move down 4. 1, 2, 3, 4. The point at 4, 2, I reflect it over the y-axis, and I move it down 4. And then I draw in my line. For domain and range, the domain starts at 0, and this time it goes toward the negative. So that means that x has to be less than or equal to 0, because the negatives are less than 0. The range has to be y, and the range starts at that negative 4, and the y's are getting bigger, so it's y is greater than or equal to negative 4. Okay, number 8, y equals 1/2 absolute value of x plus 7. So parent function is absolute value, which is y equals absolute value of x. The transformations, this 1/2 on the outside, it's being multiplied, so it's an a value, and it's smaller than 1, so that means it's a vertical shrink. This plus 7 that's inside the absolute value is a left 7 movement, because it's inside the absolute value. Okay, so for our graph, and draw in the absolute value parent function. Okay. Now this vertical shrink, I'm going to come back and do that in a second. I'm going to first do this left 7 movement. So I'm going to take every point and go left 7. So 1, 2, 3, 4, 5, 6, 7. Now that point, we're not really going to do any shrinking to it because it's at y equals 0. When I take this point and I move it to the left 7, 1, 2, 3, 4, 5, 6, 7, I know I'm going to have an x value of negative 6. So what I do is I take the negative 6 and I plug it into this original equation. 1/2 absolute value of negative 6 plus 7. What's negative 6 plus 7? 1. Absolute value of 1 is 1. 1/2 times 1 is 1/2. So my point is negative 6, 1/2. Now I'm going to take the next point and do the same thing. I'm going to move it left 7, and I know I'm going to end up with an x value of negative 5. So I take that negative 5 and I plug it in. Negative 5 plus 7 is 2. Absolute value of 2 is 2. 1/2 times 2 is 1. Now, the other thing I know about absolute value is that it's symmetric. So whatever this side is, the other side has to be the same. So it looks like that. Part D, the domain. Domain is all real numbers because x can be anything. The range, though, is y is greater than or equal to 0 because this bottom part's at 0 and then it goes up from there. Okay, on 9 through 12, you had to write the equation for the transformation. So number 9, we were given the parent function as y equals x squared. We have to reflect it over x, shift left 2, and up 4. So y equals, when I reflect over the x-axis, that means the negative has to be out front. When I shift left, that means I have to have parentheses. Left means I'm adding 2. So negative and then x plus 2 squared, with parentheses around that x plus 2. And then if I shift it up 4, that means plus 4 on the outside. So number 10 is y equals x squared, or y equals square root of x, vertically stretched by a factor of 3, and then right 5. To stretch by a factor of 3, that means I put a 3 out in the very front. Then my square root of x. When I shift right 5, that means minus 5 underneath the radical sign. That minus 5 has to be underneath the radical sign. You can put parentheses around it if you want, but you have to make sure that it's underneath that radical sign. Number 11 is y equals x, and we're reflecting it over the y-axis and shifting it down 6. So that comes out to be y equals negative x minus 6. Number 12, y equals log x. We're shifting it left 2 and down 2. So y equals log. To shift left 2, that means you add 2. But that has to be in parentheses. So it's y equals log of x plus 2 in parentheses. And then down 2 means minus 2. So that was the whole review. There was also a note that you need to be able to write an equation when you're given a graph, like assignment number A4. So like when you're given the graph, you have to be able to write the equation, knowing all the transformations in the parent function. And you also need to know how to graph a piecewise function. So make sure you look back at those assignments. And good luck on your test.